Okay, we continue working on surds and we multiply in brackets 7 plus 2 roots of 2 times 7 minus 2 roots of 2. Pause the video and try the question yourself. Okay, now when you try it, I can show you how to do it. 7 times 7 is 49. 7 times minus 2 roots of 2. 7 times minus 2 is minus 14 times root of 2, root of 2. Now multiplying the second number by everything what you have inside of the second bracket. 2 roots of 2 times 7 is 14 roots of 2. Positive times negative is negative, and 2 times 2 roots of 2, let's see what that is. 2 roots of 2 times 2 roots of 2. 2 roots of 2 times 2 roots of 2. Okay, what that is, let's multiply numbers first. 2 times 2, 4, and root of 2 times root of 2, root of 4, and root of 4 is root of 2, so we have 4 times 2, and 4 times 2 is 8. So actually when we multiply this number by this number, we are getting 8. We already been careful with the sign, positive times negative, negative, so we can just simply focus on the numbers. Okay, now here we checked all surds. Here are quite simple, no need to simplify them, so we're fine. Now let's deal with the numbers. 49 minus 8, 49 minus 8, we add like terms, so adding numbers, or basically here it's subtraction, isn't it? 49 minus 8 is 41, and minus 14 roots of 2 plus 14 roots of 2, as you see, they cancel each other because one is negative, another one is positive, and they are equal, so therefore here we found this answer is 41. The next question. 2 plus root of 6 times 4 minus root of 3. Okay, pause the video and try the question yourself, and then compare and correct if need with my solution. Okay, now let's do it. 2 times 4 is 8. 2 times negative root of 3 is negative 2 roots of 3. Okay, 6 times 4, square root of 6, or yes, square root of 6 times 4 is 4 roots of 6, and positive times negative, negative. Square root of 6 times square root of 3 is square root of 18. Okay, we expanded the brackets. Now we need to check each surd, whether we can simplify it further. For square root of 3, nothing, it's already prime number. Square root of 6 doesn't have any factor which would be a perfect square. It has factors only 1, 2, 3, and 6. Right? 1 is not interested really perfect square, so nothing can be done to simplify this further. And let's see square root of 18. I suspect that we can do something with square root of 18, because 18 has 9 as a factor, which can bring us to a much simplified version of square root of 18. So if we represent 18 as 9 times 2, then we can write square root of 9 times 2 as square root of 9 times root of 2. So square root of 9 is 3 times root of 2, which is 3 roots of 2. Okay, so let's now go back to our expression, rewrite everything what we had, and let's replace our square root of 8 with 3 roots of 2. Okay, and now let's see all surds. Each surd is different. Okay, we can't add, subtract, we can't do anything with them because they are like different unities, so you can't really add them together. And so therefore that is final solution for us. We can't simplify this expression any further. So and now we are left with the final question for today, which is this question. 1 minus 2 roots of 10 multiplied by 6 minus root of 15. Please pause the video and try the question yourself. Okay, hopefully you will see what we'll do here, okay? Right, multiplying each number by each number in the second bracket. 1 times 6, 6. 1 times negative 15 is negative square root of 15. Yeah? Square root of 15. Multiplying this negative by positive, the result will be negative. And multiplying 2 roots of 10 by 6, 2 times 6 is 12. And multiplying by root of 10 is root of 10. Now multiplying this negative by this negative gives me positive. Okay, multiplying 2 by, so basically what we have with the numbers here, we have 2 roots of 10, okay, multiplied by root of 15. Okay, we know that we can deal with this. We can write this as 2 times root of 150. Yeah, so that's what we will write, 2 root of 150. Now we'll check each third, whether it can be simplified any further. Think for square root of 15. 15 has factors 1, 3, 5, 15. None of them is a perfect square. So there's no way we can simplify it any further, so it stays as it is. As we already know, square root of 10 is just 2 times 5, so nothing can be simplified here. Square root of 50 might be simplified. Square root of 150, if you think about this, which perfect square can go into this expression, I would suggest, so you understand that 25 can be a factor. I have 25, and how many 25s will go into 150? If I will think about 150 as 150, then there are 4 25s in 100, and there are 2 25s in 50. So altogether I have 6 25s altogether, right? So therefore 150 is 25 times 6. I believe it is the biggest perfect square that I can find here, because 6 is just 2 times 3. It doesn't contain any perfect square at all that I could use. So I'm kicking out 25 out of square root. How? This way. Right? This way. Square root of 25 is 5 times root of 6. Yeah? Okay, now let's go back to our expression. 6 minus root of 15 minus 12 root of 10 plus 2, and instead of root of 150 I'll put 5 roots of 6. Okay, now let's tidy up. 6 minus root of 15 minus 12 root of 10 plus 10 root of 6. Let's check our surds. They're all different. They all cannot be simplified any further. So, and the whole expression cannot be simplified any further. That is the final decision. So that is the final question that I wanted to do with you today. Thank you for watching.